Well, this is Magic. When learning physics gets magical, let's do question 21. So, in question 21, you have a graph that looks like this. It's a velocity against time graph. A cyclist is moving up a slope that has a constant gradient. So, this is a cyclist going up a slope. The cyclist takes 8 seconds to climb the slope. So, from here to the top of slope, time is equal to 8 seconds. The variation of time t of the speed v of the cyclist is shown in the figure. Use the figure to determine the total distance moved up the slope. You got vt graph. You have to find the total distance moved up by the slope. So in this question, A, total distance. Technique we use called counting the squares. Means you have to allocate a rightly shaped square big enough so that you don't spend too much time trying to decide how many square it is. So, what's the area of one square? Let's say we choose one square here. Let's see what's a good shape. I'm going to choose something really big. So it'll be 2 seconds times 2 meters per second. The second cancels out, so it's 4 meters. So my square is around this. Now you have to count how many squares there are. Okay, hopefully you count it. Let's call number of squares of that size equal to x. Therefore, after that, total distance will just be equal to 4 meters times x. And it should give you roughly around, because it's a graph, there's always a range. You're looking at 38.5 meters to 39.5 meters. Okay, bracket to show that these meters belong to both of them. What the advice I say when you're counting your squares, just make sure you label it. For example, this is 1, this is 2, this is 3. Don't just tick it. If you tick it, you take some. If you want to recount, it will be problematic. If you do this, there's no need for recount. You'll be able to, for example, if we have squares here that is not complete, that means you are able to add your squares. For example, in these two, you can actually label them as 5. Because together, this area and this area will give you square 5. They'll make it a lot easier so that you don't need to actually recount. Okay? The key is the physics. This one should just be something that's done quick enough. Then we go to the next part once you get that ready. B. The bicycle and cyclist have a combined mass of 92 kilograms. The vertical height through which the cyclist moves is 1.3 meters. So this is h equal to 1.3 meters. For the movement of the bicycle and cyclist between time t equals 0 and t equals 8 seconds, use the figure to calculate the change in kinetic energy. So suddenly they ask you, what is delta Ek equal to? So what is delta Ek? Delta Ek is equal to half mv squared minus half mu squared, also equal to half mv squared minus u squared. M here is 92 kilograms. Your v here, according to the graph, this is your v, this is your u, final velocity, initial velocity. So it looks to me your final velocity is 3, your initial velocity is 6. Okay? You can calculate this, pause the video, and then once you finish calculating, you should get a value of around 1,240 joules. In this case, of course, there'll be a negative sign, but don't worry about the negative sign here, they just want you to know the change. Why you losing speed? Because the kinetic energy will be a loss. Now moving on to the next component. This one is B11. So now let's go to B12. Calculate the change in gravitational potential energy. So delta EGP is equal to mg delta H. M here is 92, 9.81. Delta H here is 1.3. So please calculate that using calculator. Hopefully you get a value of around